We are EasyBus. We offer you a better experience with the public transportation service. The goals we have are to improve the experience of public transportation by reducing waiting times and uncertainties. We also want to achieve real-time tracking of buses, matching for shared transportation between users, and alternate transportation options for the user to pick. Among the features that EasyBus has, it implements real-time tracking of buses. So you can see the buses that are near within the route you selected. If the bus is taking too long, the application has the alternate transport option service that shows you the Uber and taxi price and time. It also implements the matching service for shared transportation with near users. So you can find people that is going to the same destination as you and is near you. In addition, the application has eventual connectivity setup that shows the routes that are useful for the user and is constantly checking the internet connection so the user can access the features that the application has. For iOS, we used for loops instead of iterators. We declared variables outside the loop scopes. We closed listeners and broadcast receivers. We also used multithreading. We used unchecked operations to reduce overhead. In addition, we used opaque views to optimize drawing operation. We reused identifiers to avoid creating a new object for each row in the table. Finally, we cached the route information for the recent routes to improve response times. Talking about Android optimizations, we used weak references to view contexts and weak references when accessing variables from other classes. This to prevent any kind of strong relationship that would affect the garbage collection process. We also recycled bitmaps in order to reuse the memory allocations already made up in the application. We also closed every broadcast receiver and listener that were active during the app life cycle. In addition, we used for loops instead of iterators and declare variables outside the loop scope. This prevents unnecessary memory allocations. We also didn't declare any nested classes and canceled every task execution on app state change. From the figures, we can observe that the application has an increasing memory usage when the activity has a state change. Well, this state change occurs when the phone has a rotation event. This behavior can be explained because of any strong references that exists in the application or any service that wasn't closed properly. After an exhaustive analysis of the application, we concluded that the database was responsible for the memory consumption behavior that was observed previously. This due to the fact that the database was not closed and that it was being called a lot of times. So we resolved to save the current state of the application with the onSafe instance method and pass it to the other state of the application in order to reduce the database calls. Although memory consumption over time was reduced, the average memory consumption was increased because of the need of memory for saving the current state of the application. On the other hand, When we observed CPU performance, we found out that the application was consuming a lot of resources, about 30% of the processor of the CPU, because of the threads that were called but never closed, even though they were not needed anymore. To attack this problem, we canceled every thread and a sync task running when the activity state change occurred. This was done on the onDestroy method. So we assume that if the activity was destroyed, the tasks executing were not relevant for the application anymore. Furthermore, we had another memory problem within the maps activity that we were using. This was because the maps activity was using a lot of icons that were not recycling memory allocations. As we can see from the figure, the graphics are occupying about 50% of the memory heap of the application. To address this problem, we use the Glide library to reduce memory consumption, but from the figure, we can observe that it had the opposite effect. So we conclude that it was a bad implementation of the library that should be solved for the next sprint. The Glide library is used for reducing the memory consumption of the app by recycling the memory allocations and bitmap allocations of memory.